And if you need more help or exercise or something, you can ask me. These are really important.
This is part of.
Exponents.
Oh,
Algebra, it's a part of algebra, but it is going to be like for exponents.
is it in inequalities as well?
Inequalities? Yeah, sometimes, like they are more general. They are going to be applied in the trigonometry, maybe in algebra, maybe in functions, all of them. They are going to be used in many parts of the algebra or your upcoming classes.
Okay.
If you need more assistance, I can go for them.
Yeah,
Uh,
those
uh,
last ones they seem pretty hard.
exponent laws. Let's go online and see something what we got there. They could look like this one here. Like these are gonna be the rules. This is a better version, by the way. So if you have the same, you know, like, have you idea about the exponents? This is called base,
Yeah,
this is called exponent, right?
I cannot see.
You cannot see. Okay. Yeah. Can you see it now?
Yes.
Okay. The first one is called the product of powers, quotient of powers. Are you okay with these?
Yeah.
All of them. Anything you want me to explain, or I'm gonna
How about the second one?
the quotient of powers.
Yes.
Okay, so let's go to the OneNote. So you asked for the quotient of powers. Okay, but what if you know this one here? If I have 2 power um, 2 and 2 with the power of let's say 3 and 4, and there is an addition, there is a multiplication. Can you simplify this one?
No.
So first we need to work on this one here, right? Okay. So if you have the same powers, like 2 parts, okay, this number is called the base, the big number. It is called the base, and on top of it is called exponent.
Mm-hmm.
Okay, or maybe sometimes we call this one as power. You know what is meant by 2 power 3? That means we can multiply 2 3 times, right?
Yes.
So instead of writing 2 cross 2 cross 2, we can just say 2 power 3, right? So it is
Yes.
simple. So similarly here, if you had another like bases, 2 power 3, 2 power 4, literally that means you need to write 2 3 times, right? 1 1 1,
Yes.
and then you go for, and again for this one here, 2 power 4, that means you need to write it 4 times. 1 2 3 4. So 1 2 3 4, and then you can just simplify that one by writing 2 power and adding all the powers, right?
Mm-hmm.
So it's going to be 1 plus 1 plus 1 plus 1 plus 1 plus 1. I mean, I don't know how many ones are going to be there. 1 2 3 4 5 6 7.
7.
Yeah, so it's going to be like adding the power. So in short, you would get the 7 power here, and that's going to be 2 power 7, right? This is the longer way to do it. The shortest way to do it is that you just write the base and just add the powers. 3 plus
Yes.
4, and it's going to be like 7 here, right?
Mm-hmm.
Okay. Similarly here, if instead of multiplication, the operation between these two numbers are division. For example, this one here, 2 power 4, and division, there is a 2 power 3, and there is a division this time. So what would you do for this case?
It, 4 minus 3.
Yes, so it's going to be 4 minus 3. So literally that means this is a plus power, right? Positive power there.
Yes.
Okay, so this one is positive, and this one is also positive in the denominator. In other words, when this power from the denominator comes to the numerator, it's going to be like 2 power 4 positive, and this gonna be negative. This division means subtract minus 3. Okay? So in other words, if
Yes.
this one is positive, it's gonna be negative. Easy?
Yes.
So that is what is the second law here. Um, it's not the second. It's something here as 6. Okay?
Okay.
So this positive is becoming negative when it goes in the numerator. Okay.
Ah, yeah, yeah. I just realized it's not that hard even.
Yeah. So are you okay with the, you can just look at the examples as well. So this positive power there is gonna be a negative power in the numerator. So are you okay with the product of powers?
Yes.
You add them, right? Add the
Mm-hmm.
powers. For the quotient of power, that means subtract the power. When you see a division, subtract. When you see multiplication, add. Okay?
Yeah.
Next one is a power of a power. So when you have power of power, simply multiply them. So if n is the power of m, so we're going to multiply them. So just like here in the example, x power 4 power 6, just multiply these. Yeah, 4 6 is equal to 24. Easy, right?
Mm-hmm.
And power of a product. So for this case, so instead of writing this one as x, like these individual terms, x and y. So instead of writing x power 5 and y power 5, you can write x, y, the whole power 5, right?
Yeah.
In other words, you're gonna split this one here. M goes there and goes there as well.
Yeah.
And the power of a quotient. So quotient means division. This quotient means division. And here, if you have a total power of a quotient or a fraction, you can bring this m to the individual numbers. So x power m and y power m, or you can just write xy whole power m. Okay?
Yeah.
So this is going to be the example. So it's going to be 2 power 2 and 3 power 2 as well.
Mm-hmm.
And negative exponent, really important. So if you have this negative exponent there, it can become positive exponent when it goes in the denominator.
Mm-hmm.
So in other words, the opposite example could be if I have 2 power minus 3 there, this would become when it goes in the numerator, this whole term is gonna become numerator. In that case, the power is gonna be positive.
Yeah.
So if the negative exponent is in the numerator, it is gonna be positive power when it goes in the denominator. So if you are switching from numerator to denominator, change the signs.
Okay.
Identity. X power 1 means x. Okay.
Mm-hmm.
The example could be if you are writing 2 power 3, that means multiply 2 3 times, right?
Yes.
And if you are having 2 power 1, that means multiply 2 1 time, and that still is going to be 2.
Mm-hmm.
And this one here, x power 0 is going to be 1. X power 0 is going to be 1. Really important. Do you know why?
Anything multiplied by 0 is 1. I mean, to the power of 0.
Yeah, is 1. Why? Why not 0? Why 2 power 0 is not equal to 0? Have you asked this question yourself?
No.
Okay, let's try that. Let me answer this question. So, Willard, what do you think? If I write some numbers here, maybe like 2 power 1. It's gonna be like this, right? Willard, can you hear me?
Yes, sir.
hmm So, do you see the power is increasing here from 1, 3, 4. 1, 2, 3, 4. The numbers are increasing on the right side.
Mm-hmm.
So what if I'm here at the number 16 and I want to go to the previous power, that is number 8. What would I do with this one?
With what?
I would divide it by 2, right?
Oh, yes.
And I would get the previous number. So what if I am here at 8 and I want to go to the previous number? What would I do with the 8?
Divide by 2.
Perfect. And similarly here, this trend goes on. So if I'm here at 4, I divide it by 2 and I will go back to the previous number, right?
Yes.
What if I want to move further from to the previous number? I want to know what is going to be that number. Divided by 2, right?
Mm-hmm.
And if you divide 2 by 2, what would you get?
1.
1 here. And here, in the same way, the power was decreasing. 4, 3, 2, 1. And here, the power is going to be 2 power.
0.
Perfect. So here you see 2 power 0
Mm-hmm.
is going to be equal to 1.
Yes.
So I hope you won't forget this one here. So 2 power
Yeah.
0 or any number with the power of 0 is always going to be equal to 1. Now you might know why.
Yes.
Okay, perfect. So that is about something about exponents. We can work on them as well if we need that. So what do you think about quadratic? Okay. Have you studied the logarithms? Willard, have you studied the logarithms?
Uh, Basically, yes, but I haven't attended.
Okay.
I haven't attended math, so
So,
yeah, the teacher did teach, but I didn't do anything.
okay, forget about the teacher. So for now, you can say yes or no. If you say yes, I would skip that. But just in case you need
No,
more help or you need something refresher in that, you can say no. I would assume that I know that you might have studied this in the class or something, but you still need a refresher.
no.
These questions are the basis for our math. So I want you to be all prepared for all of them here because we would be applying these things. Okay?
I have no idea about logarithm.
Okay. I'm gonna mark this one as asterisk. We will come to this thing. What do you think about the radical properties? Yes or no?
No.
Okay. So, about exponent properties.
Which one is it? It's
Like these ones. We have already discussed that. I just want to make sure
yes, yes, yes,
it's
yes.
all okay, right? 10 out of 10, right?
Maybe like need a little bit of more practice, but yeah, I
Okay.
have an idea about it.
So, how much marks you would give yourself when it comes to the application of exponent properties out of 10? 10 being the best,
Maybe like
1 being the worst. Yeah,
yeah, maybe like 7, 8.
7, 8. So it means we are good. So we will be coming back for whenever we need them. So
Yes.
okay. So next one is the radical properties. So let's start with the radical properties. But the thing is, if you are good with the exponent properties, so it's not going to be a problem for you when we will discuss the radical properties. So today I'm gonna start topic with the radical properties. Okay.
Mm-hmm.
So let's open the book here. So this one here, radicals and surds. By the way, what is meant by a radical and what is meant by surd? So here is a quick review of the things. You can just read here, and if you need some help with this one, any clarification, you can ask me. And then we're going to go towards the properties. So in next few minutes, you can expect some basic operations with the radicals and the properties of radical. This one is the core topic here, the properties of radicals. And after that, these are the some of the properties that we will see. So this is for your own reading.
Yeah, I'm done.
Okay. So what is a radical? You can just tell me in your own words, in your like how you understand this thing. So what is a radical?
Uh, it's squared numbers.
Yes, square rooted. So something that
Square
has a
rooted, yes.
square root. You know, radicals are just whenever you see a square root, that is a radical. Okay? Simple as that. And we call them, sometimes we call them surds. So if I had this one 4 number, it's just a number. But when it comes with the square root, then we are going to call this one as surd or maybe radical. Okay?
Mm-hmm.
It is going to be the reverse of square. So if you have this one here, 2 squared, that's going to be 4, right?
Yes.
And if you square root 4, it's going to give you this number 2. Okay?
Yes.
Okay. So, um, so if I say, what's going to be the square of 3? 3 squared is going to be 9, right? And if I
Yeah.
say, what's going to be the square root of 9? So it's going to give you this number 3. Okay?
Yeah.
And how? It's going to be like 9 can be seen as 3 squared with the square root. This square and square root, they are enemies. They cancel out each other. So you would be left with 3. Okay?
Yeah.
And one more thing. This radical sign for x is just like saying, by the way, there is going to be invisible 2 here all the time. We usually don't write this one here, but it is always there. So it's going to be like x power 1 over 2. Okay?
Mm-hmm.
So if we have this one here, x with the third root, so it's going to be like x power 1 over 3. So whatever the index, this is called the index. This index is going to be the denominator here. So in general, we can say x with the nth index is going to be x power 1 over n. Okay?
Yeah.
Okay. And by the way, this number inside this square root cannot be negative. This number is always going to be positive. It can be
Mm-hmm.
0, but it cannot be negative number. So if you see here negative 1 with the square root, negative 2 with the square root, for your case, this is not possible. This is going to lead you towards the imaginary number, but that's not the topic of the day.
What's the square root of 0?
0.
Oh, okay.
The square of 0 is 0. The square root of 0 is 0.
Okay.
Okay. And let's go with some operations with radicals. So as I said that this one is gonna, whenever you see this sign with no index here, the 2 is gonna be there. Okay?
Mm-hmm.
So this square root and square, they are gonna cancel out each other. So eventually you would get here like 5 for this one. So this is an explanation here. You can just read, think like this one.
Mm-hmm.
And the B one as well.
So you're saying, wait,
So for A, the shortest way to think this question is square and square root cancel out each other. Simplest way is that. So you would be left with 5. Okay.
yes,
And the longest way to think is Y is that before we can go for this question, let's go. It's gonna be like 5 power 1 by 2 multiplied by 5 power 1 by 2, right?
yeah,
And when you have the same basis, what do you do with the powers? You add them.
add them,
Add them.
yes,
So 1 plus 2 and 1 plus 2. So half and half becomes 1 full, right? So
yes,
it's going to be 5 power 1, and that's going to give you the 5, just like the author has mentioned. Okay?
yeah,
Okay. So here we can have a radical number. Let's say that b with the power with the radical sign, and there is an a. The real example could be 2 multiplied by 3 square root. So this portion is going to be called as radical, and this one we can say this is the coefficient of the radical. Okay?
yeah.
So this is another way to think about the same thing. So what do you think about if I had this number like this, x power 3, I can express it as x 3 times, right?
Yeah,
So it's gonna be like
x times x.
perfect. So similarly here, if I, instead of x, I have this something here, 2 square root of 5. I need to write this one as 3 times as well, right?
Yeah,
And then you can multiply the coefficient with the coefficient. So the coefficient is r, 2, 2, and 2. I can multiply them separately, right? And the
yes,
radicals, which are again square root of 5, square root of 5, square root of 5. So I can multiply them separately, right?
mm-hmm,
So here I'm going to have this one 2 cross 2 cross 2, that's going to give me 8. And for this portion, okay, so Willard, what do you think? If I have this x square root multiplied by x square root, what would I get?
you will get x.
X, perfect. So here I have this 5 square root, this 5 square root. I would get 5 for these two, right?
Yes,
And this one is just left over there like this. So 8 fives are 40 and 5 square root. Easy?
mm-hmm,
Okay, let's solve some questions here. So I have the square and the square root. They are enemies, so they are gonna cross each other. So answer is gonna be 7, right?
yeah,
For this one here again, so I have this square root and square. So answer is gonna be just 13. All these questions.
yeah, same.
Okay, so just by looking at the questions here, what's gonna be the answer for D?
24.
E,
1 over 3.
perfect. And F,
1 over 11.
so all these questions are gonna be the similar ones. So let's go for the other questions. So here I have for now I don't have the second index. Now I have the third square root here. So for this part, what do you think? Before that, all the questions we were solving, there was an invisible 2, right? The second,
Yeah,
so that was quite easy to. So the thing is, if we have this second index and there is a square, they are going to cancel out each other. Similarly
yes,
here,
same here.
same here. So if we have the third root and I have a cube here, so third root and cube, they are going to cancel out each other. So it's going to be like 2, right?
Yeah, yeah.
And what do you think about this one?
-5.
Yeah. And here for C,
1/5.
1 over 5. Perfect. So this time we're gonna multiply the coefficient with the coefficient and radical with the radical. So we have the same radicals, like square root of 2, square root of 2, and 3 and 4 are the coefficients. So multiply the coefficient with the coefficient. That's gonna be like 3 cross 4, and we just write the radical. So it's gonna be like 12 second square root of 2, right?
Yeah.
And similarly here, can you solve the question B?
Yes.
Yeah.
1 second.
Yeah.
Mm, yes. -2 square root 3.
You, okay, so how many radicals you see here?
2.
2. So what's the coefficient of the first radical?
-2.
And what's the coefficient of the second radical?
5.
So you multiply the coefficient with the coefficient.
Yes.
So this one is going to be multiplied here 5, and you just write the radicals here. So it's going to be like -10 times square root of 3.
Yes.
Okay, so what do you think about C?
-6 square root of 5.
Perfect. Wonderful. Okay, so here we go now. Again, for the D.
-2. 6 square root of 2.
-2 multiplied by -3. What would you get?
6.
Yes, so it's gonna be like 6 times square root of 2. Perfect.
Yeah.
And for here, for the next part, E. Okay, so for this part, let me explain that one first. So if you have the coefficient, let's call this one as C as coefficient, B as the base, and square root of something. Okay, so if you have the squared, so you can just think like, what if I had this one as x and y to the whole power 2? Can you simplify this one here? Can you break it down?
Which one?
The x, y whole power 2.
Oh, yes, yes.
So it's going to be x squared and y squared, right?
Yes,
So
yes.
similarly here, if you have this one c, just imagine this is x. So it's going to be like c squared, and the y is b square root, and this is also going to be squared, right? So it's like shifting the power.
Yes.
So for the question E, just think like this one here. So it's going to be like 3 squared and square root of 2 squared, right? So 3 squared is going to be 9. And you know that this square root and the square, they cancel out either. So it's going to be 2 here. So 9 2s are 18. Okay?
Yes.
So can you solve this F part? Do the same thing.
It
3 cubed.
9, which is
We will see that. We will see that in our next step. So 3 cubed
okay.
and square root of 3 cubed, right?
Yeah. Yes.
Okay. Let me take this question to OneNote and explain it with some explanation. By the way, there is less than 1 minute, and after that we need to rejoin the session.
Sure. Okay.